by William James, also mentioned today. William James described consciousness as a wavy stream which brings all the contents. So if you try to merge those two metaphors, you get something like this, and this is actually the wave of consciousness. Again, we can see the wavy stream of mind, which comes along this axis of time. And if we take a cross section at some instance, at some moment in time, we get what Titchener used to call consciousness. This is a structure which consists of two levels, the dark or bottom level and a top or bright level. And this axis depicts sensory clearness. Some contents of our consciousness can have high intensity. Let's say that would be some bright light, but at the same time we can keep our attention on some other contents. At the same time we can keep our attention on very dim spot of light, and in this example we would have low intensity of some sensation but high sensory clearness. So when contents come into consciousness, they may rise from the bottom level to the top level, from one level to the other. The sensory clearness may change, and within the terms of this metaphor, we would call it, we would describe it as the content is rising on the crest of the wave of consciousness. So, why are we going that far? Titchener also proposed 4 laws of attention more than 100 years ago. That was 1908, and I briefly described already first laws, but the third law and the fourth law are very interesting in terms of our today's topic. The third law describes accommodation of attention, which is a hypothetical process which provides the best conditions for the rise of a particular sensation to the maximal clearness or to the crest of the wave. So if accommodation of attention takes place, then it results in higher degree of clearness for the particular sensation and faster rise into the crest of the wave. So actually in this picture we should have something like this. So we should have different maximal degrees of sensory clearness for each moment of time. And the fourth law, which is called the law of prior entry, says that the stimulus for which we are predisposed requires less time than some other stimulus to produce its full conscious effect or gain to climb to the crest of the wave. The same in Russian, because the text I cited here is not translated into Russian, but we have an analog text from Titchener's textbook on psychology, which is translated into Russian. Says basically the same thing. So to summarize, accommodation of attention, as it was first proposed by Titchener, is a hypothetical process of preparation which facilitates effects of attention, such as facilitating information processing and probably facilitating and probably enrichment of the perceived or some other content of consciousness. Also, accommodation, we also can hypothesize that accommodation leads to the speed up of the focusing of attention and to the speed up of attentional switches. No, oops, I'm sorry. now let's come to a phenomenon that accommodation of attention can potentially approach as can potentially account for. That's first of all, that's facilitation of the reaction time when we use a warning signal procedure. There is a big body of studies on this topic, and there is no single conclusion about what for a period for the warning signal is the best period to produce the full accommodation of attention. So there is a very good review paper actually back in 1981 which summarizes all the work of about 100 years of research by that point. And so far there is probably no better review than that. And this review describes 9 different factors which actually affect the best for a period from the warning signal to the actual target stimulus, and those 9 factors can be effective for different tasks. Also, there is a very important distinction. There are short periods of time and long periods of time. And let's say up to 500 milliseconds. The best for a period is about 150 milliseconds, and after the 500 milliseconds, all those 9 factors apply. Also, there is a set of studies about adaptation of perception to a certain rhythm of stimulation, which says again that the magic period of time is about 500 milliseconds, sort of a magic number in perception of time literature. Then there is a big body of research on orienting of attention in time, or temporal orientation of attention. This means that you can predict at a certain moment when the stimulus appears, and you can tune your attention to a certain moment in time. And then there is a very interesting phenomenon which was described only recently, but again reminds us of the notion of accommodation of attention. So actually, what we are looking at the top part of the screen is a rapid serial visual presentation. This is the demonstration which looks almost as about it should, of course with all the delays due to the projector and the laptop presentation way. But at least it gives you an idea of how it works in the real experimental setup. This is about 10 stimuli per second, which is a very common presentation rate for rapid serial visual presentation, and this is why it's called rapid. And for example, in this stimulation, I can ask you to say which letter was in red. So all distractors are in black, and the target letter is in red, and someone has already said that the target is S. That's true. But sometimes some people might say that it's K or A, it depends on, and if you see another letter in red, that's nothing wrong with you. This is called intrusion error, and also is quite common in rapid serial visual presentation studies. What is attention awakening? The phenomenon that was recently described. As you can see, it was described by Japanese researchers. First publication is 2005. And this is probably why the phenomenon is called in this poetic manner attentional awakening, but not accommodation of attention as Titchener called it, borrowing the term from physiology. The point is that when you have a rapid serial visual presentation stream and you have only one target, then your performance depends on how far in the stream the target is embedded. So again, this is an example of rapid serial visual presentation depicted along the time axis as it usually is depicted in papers. And the only point I would like to draw your attention to is in this study we are going to talk not about legs, like this is usually called leg 1, leg 2, leg 3, leg 4 and so on, but about beans starting from the second position in time. So 3 legs turn into one bean, and this is the first bean, second bean and third bean. So this is just to let you know about the time and scale. And this is the graph from paper of Ariga and Yokosawa 2008, which shows the gradual, what they call awakening of attention. So this is the performance, and as you can see at the first bean, which is actually positions from 2 to 4, the performance is not great, but as soon as we go through the arithmetic stream, we become better and better, and at a certain level we come to a sort of plateau. So what is important, they describe the difference of this phenomenon from attentional blink phenomenon. I think most of you are also familiar with the attentional blink phenomenon, and the key difference is that in the attentional blink phenomenon you have 2 targets, and the drop in the performance for the second target that you have in the attentional blink is because of the processing of the first target. But here you have no first target. So if you think of this part of the graph, a drop of the performance, then you should only say that it's probably because of the beginning of the task, but nothing more than that. So this is why this is often described in terms of a preparation cost. Now, last but not the least, is phenomenon of so-called temporal displacement, which is the whole set of phenomena, and the examples would be a situation when you have 2 stimuli separated by no more than 500 milliseconds, and if those stimuli or those perceptual events come at the same time, sometimes you may perceive them as sequential. If you have 2 sequential stimuli, sometimes you may perceive them as simultaneous. And again, for 2 sequential events, sometimes you may perceive them in a reverse order. This is a modification of complicational experiment I used long ago, just to give you the idea of what might happen. Again, this is an arithmetic stream, and at a certain point of this arithmetic stream, we have a key event, which may be a sound, for example, and if you ask your subject at which point of the arithmetic stream there was a sound, you may get various answers which would call positive temporal displacements if you move this way, or negative temporal displacements if you move this way. If you report the previous event, that would be negative displacement. If you report the following event, it would be positive displacement. This phenomenon is also known for many years, and it was described by Titchener as one of the examples of accommodation of attention, because according to Titchener, you may attend more to one stream of events or to another event. And if you attend to one type of events more than to the other, then this type of events come to the crest of the wave faster than the other. So the accommodation of attention would create this temporal displacement. I'll skip this. And now let's briefly switch to the data I have. First, a couple of words about the purpose of this study. Actually, there is a Russian tradition of studying the aspects of attention. It's probably not known abroad very much. And at some point it comes from the very beginning of Russian experimental psychology, which was also tightly connected with structuralism. And this is a picture of Georgy Chilpanov, who was the founder of one of the Russian, one of the Moscow psychological institutes. The institute is still alive. Chilpanov once noticed that accommodation of attention, which then they studied at their demo laboratory classes with his students, should be a certain aspect of attention that has great inter-individual variability. So some people can accommodate their attention very easily, but other people cannot do this at all. But the problem is that since then, as far as I know, no one has measured this in some way, and this comes occasionally from one textbook to another as an anecdote, like some people can, some people cannot, but we have no way to measure this. So I tried to create a short procedure which would allow me to measure a certain optimal period of accommodation of attention for a certain subject, so that I can use this procedure in a longer study to manipulate accommodation of attention in my subjects. The idea was that focused attention decreases the pattern masking effect. If you're able to focus your attention at the moment of time when the masked stimulus is presented, then the masking would occur with less probability than otherwise. The other point was that it's very hard to establish a reference frame for the accommodation of attention, because it's a volitional process. And in fact, you can start thinking of the upcoming stimulus at any point of time. And I cannot control for that in my experiment. So how do I force my subjects to start their accommodation at a certain point of time? Of course, I cannot do this. But instead, I can guarantee that at a certain point of time, they are definitely not attending to the next stimulus yet. So this is the point in time when they have to do something with the previous target stimulus. So this is why I incorporated the whole series of target stimuli into the trial, and I varied the inter-target intervals. And now I also took only intervals which are longer than 600 milliseconds to avoid any interference with the attentional blink phenomenon. Because after the first target, there would be 600 milliseconds for which the attentional blink phenomenon would apply if I put my second target within this interval. Now, this is how the procedure looks. It actually takes about 5 minutes per subject. So probably today I would make it a bit longer, but this is how it was. And this is a stream of stimuli. Those are alternating nonsense sequences. And those are stimuli words which were selected among Russian high-frequency nouns, 6 letters long, and then filtered through the procedure of lexical decision task to select 60 words which would have very, very similar reaction times in lexical decision task. This is just to decrease scatter for the recognition time. And those are masks which surround each target. And what subjects have to do, just sit in front of the screen look at this rapid sequence and read aloud as many words as possible. The key manipulation is this variable interval from 600 to 1600 milliseconds. Of course, it was randomized, so there is no a certain structure, temporal structure within this sequence. Now there were about almost 120 subjects, and what is also important is that 24 subjects were tested more than one time. These are examples of individual data sets, just to give you some sense of what's happening. Everything is very wavy in this topic, so it's again sort of a wave. And there were 10 words per accommodation interval, and this is a typical result unimodal with 1200 milliseconds optimal accommodation interval. Another result with a flat optimum, and another type of result which is actually bimodal, so we cannot tell which is the optimal interval out of those 6. In fact, 84% of individual results were like this or this, and only 16% were everything else, so patterns like this or flat patterns. Now, this is overall data, which is depicted in gray, and black and white lines show the results for 2 different situations within the procedure. So black shows you accuracy for those stimuli which were shown after the previous correct response, and white shows you the accuracy for that stimulus which followed the missed stimulus. So what is important about the shape of these curves? Actually, that's the same distribution. The difference is not statistically significant, and this means that it doesn't matter whether you can recognize the word or it is masked. It works as a reset point for your accommodation. So at least you can see masks, and this point, when you see the mask, works as the trigger for the next sequence. So there is no difference whether you are aware of the word or you are not aware of it. The next cycle starts, your accommodation of attention starts, and the cycle repeats. This is more about individual differences, and this is the distribution of optimal intervals for the subjects. And as you can see, most subjects have their optimal interval at about 1200 milliseconds. Now about retests. What you are going to get when you test people for the second time. Unfortunately, there were only 24 subjects who were available for the second test. And as you can see again, most people showed the same result at the second testing, which actually was from 6 to almost 300 days after the first test. And again, as you can see, with the shorter test periods, you get better results for stability. I wish I would test more subjects at some point to get some real test-retest statistics. So now, what we see is that the optimal period of accommodation of visual attention can be diagnosed in 84% of subjects. Also, we can talk about dynamics of preparation, and we can rather talk about some facilitation of processing than just mere preparation cost, because we see the certain oscillations on the graph. So it's not like we come to a certain plateau and then we can maintain the certain state of attention forever. And also what is very important, that accommodation of attention works after any stimulus, despite whether it's recognized or not, whether we're aware of it or not. Now I think I have to skip my second part, which actually includes the ideal observer. Probably not that idea. And I'm ready to questions.
Thank you very much. Question? Yeah.
I didn't understand the method actually. So there were several targets separated by the time from 600 to 12 to 1500. Okay. So when did they have to name the words?
They named...
Did the naming itself interfere with the period of accommodation?
That's a very good point, and this is actually one of the reasons why I created this graph with the separation between hits and misses. They named the words as soon as they could, so they named at the same time as they watched for the next target. And of course that could produce interference. Because they respond at the same time as they keep watching. The point is, if we have the difference between those two curves, a hit after hit and a hit after miss, then we might conclude that there is an actual interference. But it looks like that the previous report doesn't interfere into the process of attentional preparation, which is actually really strange. But instead, they do even better after hit than after miss.
So maybe you could shortly translate your answer.
Okay. The other way. Вопрос был, испытуемые дают ответ в процессе продолжения пробы, влияет ли это как-то на результаты. Собственно, ответ заключается в том, что как раз в том числе и по этой причине мы проверяли, различаются ли ответы после того, как слово было опознано правильно, и после пропуска, потому что действительно существует такая существенная опасность, что когда испытуемый дает ответ, то весь процесс последующей преднастройки нарушается. Вообще это было бы логично. Но тем не менее результаты ничего такого не показывают. Наоборот, получается, что после того, как они правильно назвали слово, результаты несколько выше, хотя форма кривой та же. То есть получается, что вербальный ответ не интерферирует с продолжающимся процессом подготовки, как бы странно это ни звучало.
Вербальный ответ был в обоих случаях, правильно или неправильно?
Нет, если неправильный ответ, значит,
он промолчал.
то он промолчал, да, там вербального ответа нету, он ничего не увидел. Единственное, что я туда же включила неправильно опознанные слова, но их было на самом деле очень немного.
Интерпретация количества результатов. Почему 1200?
Почему 1200? Не знаю.
The question was
why exactly 1200? Actually, I don't know. That's fortunately that's not a magic number, because magic number would be 1500. Собственно, есть еще магическое число в районе 1,5 секунд, которое идет от того же самого тичинера. Счастье, что хотя бы не оно. Почему, не знаю, потому что с механизмами здесь все еще несколько сложнее, очень мало вообще исследований на эту тему, из которых можно было бы что-то извлечь. Что могу сразу сказать, что это зависит очень сильно от процедуры и используемых стимулов. То есть для новой задачи, для нового типа стимулов нужно всякий раз конструировать, немножко видоизменять вот эту процедуру. Но благо для зрительного поиска во времени их конструировать достаточно легко. Если мы вместо слов возьмем что-то другое или изменим немножко способ предъявления, будет не 1200, будет что-нибудь еще. И еще, что печально, нужно на самом деле было, конечно, померить дальше, что после 1600, потому что там явно еще какие-то колебания, и там, может быть, будет еще. So the translation is that first I don't know why exactly 1200. Second, I know that this would change if you change the procedure like type of material or the way of the presentation. Fortunately, there are a couple of papers showing that at least attentional awakening is very specific for the task condition. And the next is that we should probably get more optimal intervals if we measure along the time axis further, because it looks more like an oscillatory process than reaching the plateau and going on.
Значит, такой вопрос. Этот механизм, он, насколько я понимаю, полностью автоматически и вообще никак с особенностями не связан. Механизм аккомодации внимания.
Вот этого мы не знаем. Ни из каких данных этого не следует. Кроме того, что это не связано с, по-видимому, с осознанностью предыдущего стимула. То есть тут вопрос в том, что именно запускает аккомодацию, при том, что предполагается, что это процесс все-таки осознанный, мы ее можем запустить сами в любой момент. Да, в ситуации эксперимента просто есть такие моменты внешние, которые нас к этому подталкивают. Собственно, проблема в том, как бы так запутать испытуемого, чтобы у него не оставалось другого способа, кроме как следовать заданной нами логике. Потому что если этого не сделать,